In this video, I will show you a project using the max3421e to create a USB host module. This video is sponsored by PCB Way. I started this project for two reasons. One was that I was fascinated by the features of the max3421e. I wanted to experiment with various USB devices to see if they could work with a microcontroller as I wanted. The other was that I had tried to include the max3421e in a previous remote control project, but the max3421e part of the circuit didn't work well. So I wanted to separate that part of the project and experiment with it. So here are my goals. First, to find out what I can do with it in some applications. I will explore the possibilities by building a simple minimal dev board and testing the integration with microcontrollers like Arduino or ESP32. Secondly, to find out which USB devices are compatible with this chip. The max3421e is a USB host device controller from Maxim Integrated that complies with the USB 2.0 standard. It is controlled via SPI and integrates USB host and device functions. It is widely used in embedded systems and is popular with hobbyists for its flexibility and reliability. I was introduced to this chip through M5 Stack's USB host module. So I decided to build my version of the USB host module. I mainly used the schematic of M5 Stack's USB host module and the max3421e datasheet. I'm using KiCad to create a schematic for this USB host module. I take care to improve the component layouts and to make sure that all connections are correct. The surrounding components are mainly resistors and capacitors, and the routing in KiCad wasn't very complex. For the SPI connection, I've made sure that the circuit exposes all SPI-related pins, so that it can be connected to microcontrollers like ESP32. For future experiments, I also exposed all GPIO pins of the max3421e. In anticipation of use as a USB host, I plan to power USB devices by providing 5V from the microcontroller just as the M5 Stack USB host module did. Since the max3421e itself operates on 3.3V, I've also added a circuit to convert 5V to 3.3V for the max3421e. After I got everything done in schematic, I moved on to PCB design. Based on the schematic, I continued to arrange the components in PCB Designer. Although it's a simple board, I always take my time with this step, as it's the most enjoyable process, and I prefer to do it manually without relying on automatic routing. The PCB design is complete. The next step is to manufacture the PCB. There are several ways to do this, but typically you can either order from a PCB manufacturer or do it yourself. I find it convenient to have PCB Way handle the manufacturing process each time, saving me the hassle. Once the PCB has arrived, the next step is to solder the components. Soldering the max3421e requires a bit of precision, but the other components are all easy to solder. For the challenging max3421e soldering, I used an electronic microscope to verify the soldering results. Seems like the soldering is perfect. This electronic microscope is from Link Micro, and it's very easy to use with a large and clear screen. As you can see, it can even be connected to an external display with a larger screen while HDMI. Highly recommended. Finally, it's time to power up and do some exciting testing. First, make sure you have the necessary libraries installed in the Arduino IDE. For this part, you need the USB Host Shield Library 2.0. This time, I'd like to perform functional testing for my custom USB host module using ESP32 and M5 stack. First, connect it to the ESP32. It should work seamlessly with any type of ESP32 dev board you can get your hands on. Please make the following connections. I will show it on the screen. Once connected, run the USB description example program from the USB Host Shield Library 2.0. You can find the file here from the examples menu, locate the USB Host Shield Library 2.0, and select the USB_DESC. Then compile and flash it to the ESP32 board. After that, open the serial monitor and restart the program after connecting different USB devices to the USB Type-A port. You should be able to read detailed information about each USB device. Let me try something I have close at hand. It's a regular USB mouse, and this is the result of the program. If you search online, you'll find that vendor ID 04F2 is associated with the company Chicony Electronics. That's interesting. This is the result of the program when connected to a USB gamepad. When I ran the search again, I found that the vendor ID 081F appears to be associated with the company Menta. Again, this is the result of the program for the joystick. I ran the search again with the vendor ID 0738 and product ID 2237. I can identify it as Mad Catz Incorporated version 1 stick. Now that I've confirmed that this USB host module can identify the USB devices without problems, the next step is to test it on the M5 stack. When connecting to the M5 stack, the procedure is essentially the same, but please be sure to check the pin configuration for the M5 stack's M bus before connecting. Next, let's run the M5 stack demo program. The file can be found here from the examples menu. Select M5 stack, then select modules, select USB max3421e, and select USB mouse. Compile this program, flash it to the M5 stack, and run it. As you can see, by actually moving a USB mouse, you'll be able to draw lines on the screen. Next, with the M5 stack still connected, run the following program. You can find the program from the examples menu. Select USB Host Shield Library 2.0. Select HID and select USB HID boot mouse. I tried this program with the USB mouse used before. Run the program and check out the serial monitor. You will be able to see the changes in coordinates as you move the mouse, as well as the state of the left and right buttons being clicked. This means that we can control the microcontroller with the mouse. The possibilities to create different projects are unlimited. Next, run the following program. You can find the program from the examples menu. Select USB Host Shield Library 2.0, select HID, and select USB HID joystick. And connect the joystick to your system. This joystick also successfully captured all button states and motion values. It's amazing. It's promising, isn't it? Next, try the gamepad with the same program and reboot to see how it works. As expected, we can also capture all gamepad button values. I'm impressed. This max3421e module and the USB Host Shield library are fantastic. As you can see in the sample folder, many Bluetooth controllers are supported as well. Although I haven't verified all of them, since I don't have all the Bluetooth controllers listed here. There is one caveat though, it may not work with the latest USB dongles. But it works well with some older USB dongles. It worked well with PlayStation 3 controller and Wiimote well, even with the nunchuck. In this project, I designed, soldered, and tested a USB host module using the max3421e. I tested it with a generic ESP32 dev board and M5 stack. I successfully ran some sample codes on my USB host module without any problem, and I strongly feel the potential for applications. It's really exciting to have my original design of a USB host module. Next, I'm planning to start some projects to control things like robot arm or a toy car using my USB host module and the USB devices tested in this video. Since it works flawlessly with ESP32 and ESP32 can implement features like ESP Now, it will be easy to turn all the USB devices into remote control input devices. While the previous ESP32 remote control project represented some challenges, this project provided an opportunity for redemption. Well, I guess that concludes this video. If you find something interesting or find this video informative, please consider subscribing to my channel to see more videos like this. Thanks for watching and see you next time.